Our lesson today continues with the brief introduction that we had at the beginning of class today to talk about absolute value and inequalities. Now, what we noticed, and I think you guys did a nice job of doing, was figuring out that with absolute value, we're going to be measuring the absolute value of whatever it is being, at least for today's lesson, no further away than a certain distance. Okay, so we're going to have to visualize this for today's lesson as an and type of compound inequality. So our lesson on these problems is going to be broken down into today being and compound inequalities, and then we can expect the next group of problems to be or. So what's important for us to understand is that with absolute value, we can expect two outcomes. We know that's the case with absolute value equations. And with compound inequalities, we also essentially get two outcomes, the equivalent of those and statements, again, the focus of today's discussion, and the equivalent of or statements, or inequalities that we will talk more about tomorrow. So what we can do is we can anticipate that we're going to be solving these inequalities because they're absolute value in a way that's going to give us two outcomes, but in the context of an inequality, meaning it's going to be on a number line as well. So let's get started with the process of solving one of these. Now, as is also the case when it comes to absolute value, we always want to make sure that we isolate, and that's what was noted back up here. So let's just quickly go through. With absolute value equations, we know we need to isolate, so we do that as needed. Also, we break into two statements, and that's essentially what we'll be doing with the and inequalities that we write, and then we'll solve and graph accordingly. So in our first example, we can take a look. Is the absolute value isolated? Yes, it is. Now what this says, the absolute value of x plus 3 is less than 11. So let's visualize that on a number line. And this is what we already did in our quick discussion in class. If we think about this absolute value being less than 11, then we know it can either be no more than 11 spaces to the right of 0. So that could be where my x plus 3 is as an open dot. But it could also be no more than 11 away to the left of 0, represented as an open dot at negative 11, with x plus 3 being there. So think about what we're beginning to have shape up here. We're beginning to get a line segment that shapes up. And my graph is a little out of whack there, but we'll fix that. So essentially what we have is that our absolute value, x plus 3, is never further away than 11 to the right, is never further away than 11 to the right, and also never further away than 11 to the left. And you can see that we've essentially created an and statement, our sandwich statement. So now just go ahead from what we have experience doing, solve this as we would an and compound inequality. So we will, to solve for x, we'll subtract 3 in the middle, 3 on the left, 3 on the right. And we'll continue with our math. 11 minus 3 is negative 14, is less than x, is less than 11 minus 3 on the right side is 8. That will be our final solution. But don't forget, we need to graph this as well. So we will mark 8, we will mark negative 11, I'm sorry, we will mark negative 14, and being that it's greater than or less than, with our symbols, we'll do open dots and a line segment. So this essentially makes up our final solution. Now we could test this if we wanted to. We could take these values, substitute them back in, and just make sure they make perfect sense. So the testing is still something that we have the ability to do, even with absolute value inequalities. Now, the next problem, you can see we do have to deal with isolating first. So we're going to first have to undo the adding of 5 by subtracting. We'll have to move on to the undoing the multiplying by 3 by dividing. So let's get the isolating done first. So subtract 5, and you get 3 times the absolute value of x minus 9 is less than or equal to 18. Divide everything by 3, and you will get the absolute value of x minus 9 is less than or equal to 6. We're now at the point where we're ready to treat this as a compound inequality, specifically as an and compound inequality. Okay, we'll get more into how we can read this symbol, but this is an and statement again. So we can think of whatever x minus 9 is as being no further away than 6 to the right of 0 and no further away than 6 to the left of 0. And we can continue with our solving from there by doing as we would with any and statement, by doing what we do in the middle, also to the right and to the left. So negative 6 plus 9 will give me 3 is less than or equal to x is less than or equal to 15. And we've finished solving for x. Draw our number line because that's the last part of our solving. 3 and 15 both being positive numbers are to the right of 0. Because of our inequality symbols, we will mark closed dots. And because we're an and statement, we know that we need to graph with a segment between those points. So don't overthink these problems. And there are there are no more. Oh, I'm sorry, there are 4 more for you to do. Don't overthink these. All of these are going to be set up as and statements. So make sure you set them up as those sandwich statements as we refer to them. But just make sure as you need to that you isolate before you break into that sandwich statement and solve. So finish up the last 4 problems independently, and we'll come back to class and get more practice in together as a group.